Alright, so in this video, which is sort of part one of doing ionic bonding, we're going to figure out how to determine the common charge on these atoms. Now, if you already know how to do this, feel free to skip ahead, but if not, we're just going to go through this pretty quickly. So the first step in doing this is you need the periodic table. And when you look at the periodic table, we're going to sort of break this down into certain areas. We're going to count off the number of the columns from left to right. So I'm going to call this column 1, column 2, and we're going to skip this whole middle section for reasons we might get to later. But for now, we don't care at all about those. We're just going to number from left to right. So 1, 2, 3, 4, 5, 6, 7, 8. And so what these represent is how many electrons are in the outer shell of these atoms, which is all we really care about because when it comes to bonding, the inner electrons don't really have a huge impact. So, knowing that, that's how we're going to start this process. We're going to go back to our list of atoms, and we're going to draw what's called the electron dot structure. So first I look at Be, and I say, okay, Be is at the second column. That means it has 2 electrons in its outer shell. So I'm going to do Be, and I'm going to draw 2 dots around it to represent those 2 electrons are the outer shell of Be. Oxygen, I'm going to look, O, going back, O is in column 6, so I'm going to draw an O, and I'm going to draw 6 dots around it. And I can do the same thing with all these others. I is in the 7th column, so I, 7 dots. And the most dots you'll get is 8. Hydrogen's in the 1st column, so H with 1 dot. Ar is in the 8th column, so I'll draw with 8 dots. And Pb, just trust me, is 4. So that's the first step. And then we got to ask ourselves, okay, well, what do these atoms want to do with these electrons? Now, these atoms, for the most part, are not stable right now. Atoms are stable when they have a full shell, which typically means 8. And the other way they can get a full shell is if they get rid of an incomplete outer shell that will also make them stable. So if they have a shell that's not full, but they get rid of everything in that shell, that makes them stable. So either getting to 8 or 0 is what they want to do. And typically we try to figure out the easiest way to do this. So for example, Be has 2 electrons in its outer shell. How could it be stable? Well, it could either gain 6 electrons to get to 8, or it could just lose those 2. So of these 2 options, which one do you think is easier? It's probably a lot easier to lose 2. So Be is going to lose 2 electrons to become stable. All right, O has 6. So again, it could lose those 6, but it's probably a lot easier to gain 2. I has 7, so it's going to simply gain 1. Hydrogen has 1, so it is going to usually lose 1. Hydrogen is sort of a special case, but again, losing 1 will be the most common. Ar has 8. It's stable, so it's not going to do anything. It's already stable. And lastly, Pb, this is a little tricky, has 4. So you might think, well, it could gain 4 or it could lose 4. How do we know which? And the best way is to go back to the periodic table. And most periodic tables have what's called a stair-step line. Looks like this along it. And this sort of separates the metals from the non-metals. Metals are everything on the left side of the staircase, and non-metals are everything on the right side. And it turns out metals usually like to lose electrons because they don't have a lot, and non-metals usually like to gain them. So looking at Pb's location, it's on the side of the metals. So it's more likely, if it's going to do this bond, then going to lose the electrons. So going back, I'm going to say, okay, Pb is probably going to lose 4. All right, so we've established that. Now we just got to figure out, well, what's the charge going to be? So if Be was was neutral before, now it just lost 2 electrons. Well, electrons, as we remember, are negative. So normally, Be has 4 protons and 4 electrons. But if it then has now 4 protons and only 2 electrons, because it lost 2 of them, there are now more protons than electrons. It is now positively charged. So Be is going to have a positive 2 charge. And that's what's going to be. Oxygen, on the other hand, is gaining electrons. So if it was neutral before, it just picked up these two particles which are negative. Oxygen is now going to be -2. Iodine gained 1 electron, so that means it's going to be negative, but only -1. Now you could write 1 minus if you want. Usually just the minus is sufficient to tell us that it's -1. Hydrogen lost 1 electron, so it's going to be +1. It's going to only lose 1. Argon's stable, so it's not going to have any charge. It's going to be argon. And lead lost 4, so lead is going to be +4. You're very rarely ever going to see charges over 4. It's possible maybe to get a 5+ occasionally, but if you ever end up with a charge like 6 or 7, it probably means you just looked at the electrons and called that the charge. So if you're giving iodine a 7 charge, it means you forgot this step here where you figured out, okay, is it gaining or losing electrons? So just be careful of that. Be careful of charges over 4. You really shouldn't be getting those very often. And so that's step 1 in figuring out ionic formulas, is just determining these charges and being able to do it relatively quickly. So until next time, I am Derek Genova. Have a delightful day.